Hello. Good afternoon. Okay, so today we will start the unit number 4 is there. Unit number 4 is there. Everybody audible आहे आवाज? Hello. Audible आहे ना? Hello.
Yes, sir.
Okay. So we will start the session is there. Unit number 4 is there. This unit number 4 syllabus is there. Just go to the university syllabus. So this is the unit number 4. This is the hardware of the 8051 is there. Okay. So what is the objective of this course chapter unit is there? We have to know the hardware, introduce the hardware structure of the 8051. Means how ports are work hardwarely in 8051 is there. And then some into assembly language programming for the timers and counters are there. So this is the contents of this topic is there. Port structure study is there. Then interrupt structure. What is meant by the interrupt? We are discussing in what is meant by the interrupt? We were discussing in architecture of 8051. But here we are in deep. We have to discuss the interrupts of this. Then interrupts, special function registers of the I and IP is there. For the interrupt is there. Then structure is there. Then next is the timer. Two timers we have discussed at the time of the architecture is there. Two 16-bit timers are present in 8051 is there. So how timer is works? What are the programs related to the timers and counters are there? So we are discussing the assembly language program of timers in this unit number 4 is there. So this is the topics we have covered in unit number 4 is there. So objective of this unit is that we have introduced the hardware structure of the 8051. So discuss the hardware structure of the 8051. Okay. So this is the hardware overview of the 8051 microcontroller is there. This is syllabus. We are discussing the port structure, first point. Second point is the interrupt is there. Means interrupt, enable interrupt priorities there. How interrupts work, what type of interrupts are there in this unit number. Topic number 2 is there. In topic number 3, we are discussing the timer is there. What type of timers is there, how they are work is there, what are the special function registers of timer is there. We are already discussed the special function register of the timers, but you are in brief you are discussing this unit number 4 is there, and regarding the program of related to your timer and count is there. Assembly language program we discuss for the part number 3 of this unit number 4 is there. So we are go to the ports of this 8051. So we are discussing already the ports. This is the 40 pin IC of the 8051. We know that the ports are there. This is the port 0, this is the port 1, this is the port 3, and this is the port 2 is there. Port 0, port 1, this is the port 0, then this is the port 1, this is the port 2, and this is the port 3. So these are the ports which have in 8051. All are the 4 ports. Each port is contain 8 pins are there. Each port is contain the 8 pins are there. 8-bit port is there. You can say 8 pins they are used means that it is the 8-bit port is there. It is the byte addressable also and bit addressable. Remember these things. The port number 1, 0, 1, 2, 3 are bit addressable and byte addressable are there. Bit addressable and byte addressable are there. Means you can manage this port by using bit also and by using a byte also. Okay. So this is the port 0. See the port 0 is there. We are discussing this in pin diagram, but here this is the port D is there. Port 0, port 0 is P00 to P07. P00 to P07 is the port bits are. P0 means port 0. 0.0 means what? It is the port 0's bit 0. 0.0.1 means port 0's bit 1. P02 means port 0 and bit 2 is there. As just like this port 0.7 means port 0, 7 bit is there. So this port is act as AD0 to AD7. What is mean the AD0 to AD7? Means it is act as a address and data bus. It is act as a address and data bus. If it is 0, it is act as address. It is 1, it is act as a data bus is there. So we are discussing here is at the data bus and address bus is there. So these 8 pins are act as address bus, or sometimes it is act as a data bus is there. Okay. Next is the port 1 is there. This is the port 1. This is the port 1 is there. P10 to P7 is there. Then this is the port 1. These are the, again we have to see that these ports are bidirectional ports are there. Ports are the bidirectional ports. Why it is bidirectional port means you can read the data from port, you can read the data using port of 8051, and also you have to write the data from port to the 8051. You can read the data from port using port from 8051, and you can write the data using port to the 8051 is there. So these are the bidirectional ports. Remember these things, ports are the bidirectional are means it is act as input output ports are there. It is act as input port and it is act as a output ports. Input means you have to take the data, output means you have to, sorry, input means you have to give the data, and output means you have to take the data is there. Okay, so this is the port 3 is there, port 1 is there, then port 2, here is the port 1, sorry, here port 2. Port 2 is a A8 to A15. It is the address bus. Port 2 is the address bus, higher order address bus A8 to A20. There is no multiplexing here. Here is no multiplexing of this port number 2 is there. Why? It is all 8 pins are act as a address bus. It is act as address bus, which is the higher order address bus is there. It is not a multiplexing is there. So it is directly act as a higher order bus is there. Here is multiplexing is there means what? Sometimes it is act as data port 0, in sometimes act as a data bus, sometimes it is act as a address bus is there. Okay, this is the port number 0, port number 1, port number 2, and port number 3 is there. Then port number 3 is a, these are the pins are there. Okay, port 3 is RxD pins, means receiver. Port 3.1 is transmitter. Then interrupt 0, interrupt 1, timer 0, timer 1, read and write is there. So these are the port 3's pins are there. So port 3 is act as an input output port also, but it is act as a special function pins are there. So these are the special function pins are there, which are the RxD2, RxD2, RD is there. These are the special functions pins are there. Okay, so this is the 80, this is the 8051 ports are there. So summary of this slide is that 8051 is contain a 4 port. Each port is 8-bit port. Each port is the 8-bit port. It is byte addressable and bit addressable. Also, these ports are the bidirectional ports. Also, these ports are the bidirectional ports are there. Means it is act as input port. It is act as a output port is there. Then some ports, just like a port number 0, port number 3, port number 2. These are the ports are the multiplexing port. Means it is doing the two functions are there. Port 0 is doing as address bus also and data bus also. Port 2, it is act as, sorry, port is not multiplexing is there. Port 2 is directly act as only higher order address bus is there, and port 3 is again multiplexing with the some pins which are used for the read write or interrupts are there. It is used for the read write or interrupt or serial communication is there. So these are the port, 4 ports are there. So this is the special function registers. This is the special function registers are there. This is special function registers are P0 to P07. P0 to P07 is there. So it is the value of the retracement, value of the reset is 80H. It is the address is the 80H. It is the address is the 80H is there. Address of the port 0 is 80H is there. One port 0012 to the port 07 is there. Same here, when you are using the port 1 is there, special function register is there. You are discussing at the time of the RAM addressing mode is there. We are discussed with the architecture of 8051. In that, we are discussing the address RAM of this 8051. In that RAM, we are discussed all the register which is having special function register which is having their own address bus is there. So here is the 80H is the address bus, address of this port 0. Then this is 90 is the address of port 1 is there. 80 is the address of port 2 is there, and A B0 is the address of port 3 is there. Okay. See, the reset value of all ports are 111. The reset value of all ports are the 111. Means what? FFH. FFH. So when you have to read the data, when we have to read the data, we have to put a value of 11 in each port. I'm discussing at the time of the architecture also. I'm giving, if you are using a port as a read port, If you are using the port as a read port, you have to put a value 1 1 in each bit is there. And if you want to write a port, then you have to put a value of 0 0 in each bit of the port is there. You can use any port for that. So for the port reading port, you have to put value of 1, and writing port, you have to put value of 0 0. Why it is we are discussing at the time of the brief architecture of ports are there. Okay, so this is called a special function registers are there. Port 0, port 1, port 2, and port 3 is there. Port 1, port 2, and port 3 there. You can, in the programming, you can use the address also. In the programming, you can use the address also 8090 A0 or B0, or also address also, or you can use a port 0 and port 1 also, depending upon you can use in your programming there. Some book they are use the address for doing the program of the port, some they are used directly port 0 and port 1 is there. Depending upon the programmer, they have to use this. So we are discussing the architecture of means port 0 structure is there. We are discussing the port 0 structure is there. Okay, port 0 structure is there. So what is the port 0 structure? Port 0 structure कसे बघा आपलं? पोर्ट 0 म्हणजे काय? हे पोर्ट 0 मध्ये काय, जी काय बस आहे, इट इज ऍक्ट एज ऍड्रेस बस अँड डेटा बस. इट इज ऍक्ट एज दिस पोर्ट इज ऍक्ट एज ऍड्रेस बस अँड डेटा bus. So here we have to use the address bus and data bus, where we have to use the address bus and data bus. And again, it is act as a bidirectional port is there. I am discussing that every port is a bidirectional port. Every port is the bidirectional port is there. Means what? We have to give the data to the 8051, and you have to take the data from the 8051 is there. So it is bidirectional. So two functions are doing with the port 0. One function it is act as address and data bus, and second function is it is act as a input output. So for that purpose, they are used the mux is there. So we are discussing first parts. If you know that, yes or no, that's why I'm giving these symbols are there. So first we are discussing from this. This is a D flip-flop is there. This is called the D flip-flop. This is a D flip-flop is there. D flip-flop means what? Here I am giving the some symbol of, if you know, yes. So this is the D flip-flop is there. There is no need to see what is the D flip-flop is. D flip-flop is, this is the D is the input is there. This is the D is the input is there, and Q and Q bar is the output. See what is meant with the flip-flop? Just I am giving in one line. Flip-flop is used to store the bit is there. Flip-flops is used to store a bit. Flip-flop is a sequential circuit. Flip-flop is a sequential circuit. Why? Because flip-flop output is depending upon the previous state of the, it is depending upon the previous state of this input of the flip-flop is there. So previous state is in previous state, what is the input of the flip-flop? Depending upon that, it gives the output there. So it is called a sequence circuit is there. Use flip-flop application of flip-flop is, it is used for the shift register also. It is used for the counter also. Here in port 0, we have to use the D flip-flop. Types of flip-flops are D flip-flop, T flip-flop, JK flip-flop, and SR flip-flop. But here we have to use the D flip-flop is there. Okay. So just see. This is the truth table of this. This is the truth table of the flip-flop is there. So see the truth table. So this is the D, okay, and this is the clock is there. This is the D is the input, and clock is given to the flip-flop. See what is use of the clock is there. After giving the clock, flip-flop will change its state is there. When after giving the clock, the previous state will be changed to the next state is there. So trigger the flip-flop. Trigger the flip-flop means to say the flip-flop, you have to change your state. For that purpose, they use the clock is there. For that purpose, they are use the clock is there. So you have to change the previous state to the next state of the flip-flop. Previous you would store 1, and next you want to store is 0 in that flip-flop. So for that purpose, we have to use the clock pulse is there. We have to use the clock pulse is there. So see, when here is a positive clock pulses, when you are giving the clock pulse is 0 0. If you are giving the clock pulse is 0, there is no change in your 8051. There is a no change in the 8051. Sorry, there is no change in the flip-flop output is there. So there is a no change in the flip-flop output is there. It is as it is. It is as it is. Why? Because you are not giving the clock pulse. You are not giving the clock pulse to the flip-flop is there. So due to that, when clock pulse is 0, any change, input change in the 0 and 1 is there. If there is change of first, we have to put the value of 0. Next, it's put the value of 1 is there. But due to there is a no clock pulse in the D flip-flop is given so that their output is as it is. So that their output is as it is. Their output is the as it is there. Okay. So their output is same is there because without giving the trigger to the flip-flop, flip-flop will not change its state is there. Flip-flop will not change its state is there. So this is the use of that clock pulses. Then again, in next two steps, you have seen you are giving the clock pulse is 1 1. You are giving the clock pulse is the 1 1 is there. You are giving the clock pulse is the 1 1. After that, there will be change in the output is there. I'm not going to discuss in deep of this, but you must remember some things related to the deep flip flop is there. So if you are giving the input is 0, D0 is there. If input is D0, your output is 0 means D Q given a 0 and Q bar is given a 1 is there. Remember that when your clock pulse is 1 and your input of D is 0, if your input of D is 0, then your output will be changed, means Q becomes 0 and Q bar becomes a 1 is there. Q becomes 0 and Q bar becomes a 1 is there. Okay. Q bar becomes a 1 is there. Next, when you are changed, input is suppose 1 is there, you are replaced the Q D output, D input is 1. If D input is 1 is given, then after that Q will be 1 and Q bar becomes a 0 is there. Q becomes 1 and Q bar becomes a 0. Only summary of this point is that when input of D flip-flop is 0, if input of D flip-flop is 0, your Q will be 0 and Q bar will be 1 is there. And if input of the D flip-flop is 1, if input of the D flip-flop is 1, then Q becomes 1 and Q bar becomes a 0 is there. Q becomes 1 and Q bar becomes 0. Only remember these things because these things are required here for your latch is there. So this is the D flip-flop there. Again, another part here is we have to use in the D flip-flop. This first part is completed here. Then here they are used. This is called a mux is there. This is called the mux. Mux. What is use of the mux is there? There are the two pins are there which we have to connect it to the output is there. Which we have to connect to output. See here one pin of this is connected to the address and data bus of your port 0 and another pin is connected to the input output port of it is act as the input port of the for the 8051Z. So for that purpose, this is the mux, means these are the two inputs and here is only one output which is connected to this CMOS circuit is there. This is like a transistor or CMOS circuit is there. When okay, we'll discuss afterwards. So here is we are giving this mux is there. In mux, there are two inputs are there and one output. So this is the symbol is there. This is called a 2:1 mux is there. This is called a 2:1 mux is there. Means two inputs are there and one output is there. There are two inputs are there and one output is there. So it is called the mux is there. So two inputs are there and one output is called. This is called the mux is there. Okay, understood what is going to use of the mux is there. So here is the two inputs and one output. So it is mux is there. So when we require to connect this is there, when control is 1, see here, when control is 1, where is the control is there? When is control is 1, your address and data bus is interface. Means here, when you are 1, here is 1, you have to connect an address bus to your output is there, means port 0 is act as a address and data bus. And if control is 0, if your put control is 0, what will happen? If control is 0, then it is connected to here, it is connected to here. So it is act as a bidirectional input output port. So port 0 is act as a bidirectional of input output port is there. Okay, understood. When control is 1, it is act as address and database, and control is 0, it is act as a bidirectional port. So for that purpose, you have to connect the your pins to the output through the which it is called the mux is there. So by mux is what? How to select that pins? These pins are selected by the A is there. These pins are selected by the A. You can say it as a control pins are there. You can say the control pins are there. You have to connect by using this pin. You have to connect the mux to the input. Output is connected to the input of this one of the pins are there. Okay, so this is the mux is there. It's part of this. This is the mux. Then these are the two CMOS, or you can say as a these are transistor, or you can use it is act as switch only. It is only act as switch is there. Means if you are giving the one, if you are get the input to this one, it will be short. Means it will be switch will be on is there. And if it is 0, if it is 0, if input of given this CMOS circuit is 0, then your switch will be off is there. Switch will be off is there. Means when input of given to this switch, just if you are familiar with the transistor is there, if you're not familiar with the CMOS, if you're not familiar with the transistor is there, then what is use of the transistor is there? If you are giving the one input to the transistor, if it is a NPN transistor, if it is given the one input to the transistor will be short, means this act as a switch is there. So here is CMOS is act as a switch is there. When input is 1, it will be short, means the current will flow through this, and if it is 0, it is open, means it is act as a closed switch is there. Sorry, open switch is there. Close and open switch, so it is act as a open switch is there. Next, it is the port is there P0X. X means what? Number of pins are there when 0 to 7. Number of pins means it is the 0 to 7 pins are there. It is P0 to 7 means it is given the 8 pins are there. It is remembered as a P0X is there. It is only one pin is there. This is the tri-state buffers are there. Read switch is there. Tri-state buffer means it is act as a buffer means that what is use of the buffer is there? The input is coming from this. It is only passes through output is there. It is take input from anyone. It is there is no change on that input is there, and it is directly passed to your uh, passed to the uh, 8051 is there. So this is the use of this tri-state buffers are there. These are your buffer means what? You have to directly give the input to the means it is a mediator between the input and sorry from port and 8051 there. So only take the input from the port and it is given to the okay. This is the okay. So it is the input is given to D. This is the right bus in integer bus right, and this is the latch is there. Okay, this is the latch which means you can say the integer bus right latch. And it is a clock is there. Okay, so we all discussed the how it works is there. Here, see, port 0 can be used as normal bidirectional input port. Okay, when control is 1, just what I'm writing, just if control is 1, the port is act as a address and data bus. If the control is 0, it is act as a bidirectional input output port is there. We are discussing in previous slide is same thing is here. Then when you control 0, when your port is assigned to the port 1, a return latch and situation both the output. This is the MOSFET or CMOS is a MOSFETs are off. So we discuss the working is there. So here is the working is there. So what are the operations we are going to do in 8051 is there? Only two operations are there. What are the two operations is there? You have to write the data into 8051 or you have to read the data from 8051. You have to write the data into 8051 and you have to read the data from 8051 is there. Okay, understood. What is are the two functions are there? You have to write the data from 8051 to the port or you have to read the data from port to the 8051. So first we have discussed the write one. You have to write a data to the data to the port is there. Understood? Means you have to take the data from 8051 and you have to place data on your port is there. So what is your suppose you are connected the LED to port P01 pin is there. Suppose you are connected the LED to port 0.1 is there. 0.1 0.0 you can say 0.0 means it is the first pin of the port is there. So when you have to give the input 1 from CPU sorry from 8051 to this port, then LED will be glow is there. And if I am giving the 0 input to this uh, port from 8051, then LED will be off is there. But how it will go to the this pin is there? How what is the procedure for that to doing such a things? So see, just one by one here I am writing all these things, but see one by one is there. Hello, any problem? See what is the working is there. First what I am doing, I want to write the data is there. So what I am doing, I am going to write the data is there. So here is the write one means you have to write a data into the port. This is suppose port P0 pin is there, P.0 pin is there. Okay, P0.0 pin is there. So this is the first pin is there, you have to write data, write one. So you know that when your D flip-flop is there, I am discussing in previous slide is there, when input is given to the means D becomes 1. When input of the D flip flop is 1, then Q becomes 1 and Q bar becomes 0. We are discussing already. Then If your port is act as a bidirectional port, so for that purpose you are giving the control is 0. So control is 0. Due to that, your this mux is connected to the q bar. This mux is connected to the q bar. Why? Because I am discussing here. Here, when your control is 0, you have to connect to the bidirectional port, and if it is 1, it is act as a data bus is there. So same here, if it is a control is 0, so you have to put this pin to here. So you have to connect, means port 0 is act as a bidirectional input output. It is act as a bidirectional input output port is there. Okay. So see what will happen. So here you are giving the input to 1 is there. So this is goes to the D. So Q1, Q bar is 0. Then here is the control is 0. So mux is connected to this. So this input is given to the 0 is there. After that, this control is 0. This control is 0. So if you know the truth table of NAND gate, if sorry, truth table of the AND gate, what is the truth table of AND gate is there? Just I'm writing here. Here I'm giving the truth table of this one is there. So just see 0, 0, 0, 1, 1, 0, and 1, 1 is there. Okay, 1, 0, and 1, 1 is there. So what is the truth table? If anybody know that truth table, if anybody know the truth table of that, so 0, 0, it becomes a 0. If 0, 1, it becomes a 0. 1, 0, it becomes a 0, and 1, 1 becomes a 1 is there. So from this truth table, these are the two inputs are there. This is the output. From this truth table, you can understand that if any input of the AND gate, if any input of the AND gate is 0, if any input of the AND gate is 0, then output is 0. Maybe the any input, another input is 1 or 0. It doesn't matter. Here, if one input is 0, there may be second input is 1. There is no matter because our output is 0. If it is 1, but input is 1, input is 0, so our output is 0. So from AND gate, any input is given to the AND gate is 0, then obviously our output is 0 is there. Okay. So here control is 0, so you are giving the 0 is there. 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 Okay, understood? So due to that, what happens? See, due to that, this MOS is 0 and here is also 0 is there. So these two inputs are 0. This is the 0 and this is the 0 is there. Then what will happen? This will be off and this will be off. Then how the output is given to that float? This is the again port 0.0x is the pin is the float pins. So due to that, what happened? We have to transfer the what we have to transfer the right one is there. So for that purpose, we have to use the pull-up register. We have to use the pull-up register to this port is there. So I'm at the time of architecture, I'm saying that when we are using the port 0, when we are using the port 0, we require the external pull-up register. So this is the question is asked at the time of your online examination. Which port is having the external pull-up registers? Which port is there? Port 0. Why? This is the reason for that. For that reason, we require the external pull-up register to this port 0 is there. External pull-up register is required, so port 0 is there. Okay, understood. So for that purpose, we require the external pull-up register is there in 80, sorry, port 0 in 8051. Remember, this is a very important question at the time of your oral examination and also at the time of the practical examination. So if you don't know the structure of the 8051, only one question asked the examiner, that why we require the port 0 with pull-up register. Why we require the port 0 with pull-up? This is the reason why we require the pull-up register for the port 0 is. Okay, remember, see, just I'm collectively I'm telling all these things. So when you connected this port 0 is a pull-up register. So this VCC is connected to this port 0 and this VCC goes to the outside. So this right one means what? Plus VCC, and 0 means what? The 0 volt is there. So plus VCC directly connected to the port 0 and this will be the output of this. So this will be the output of this port 0 is there. So this will be the output of the port 0 is there. Okay, understood? So this is the This is the working of this port 0 for the write operation. This is the working of the port 0 for the write operation. Okay, understood? So we will discuss in, we'll discuss all in one sentence, then we can understand. Okay, see, see the working I'm telling one by one. Just I'm giving the one part, some parts regarding this, between this working is there. So see, when I'm giving the first step, you are giving the right input from the CPU, means from 8051 to the port 0. In port 0 is connected to the, means this input is goes to the D flip-flop present in port 0 is there. Then D flip-flop is one input is there. So due to that, Q becomes 1 and Q bar becomes 0. Q becomes 1 and Q bar becomes 0 is there. Due to that control pin is 0, you are connected to the mux is connected to the Q bar is there. Mux is connected to the Q bar is there, so it is acted as a bidirectional put is there. Due to that AND gate, the control is 0, so output of the AND gate is 0. If control is 0, so output output of the AND gate becomes a 0. Output of the AND gate become a 0 is there. So output of the AND gate becomes a 0. Due to that, this is your you can say the MOSFET circuit or switch circuit will be off is there. Here your MOSFET mux is connected to this Q bar is there. This Q bar is connected to here. This Q bar is connected to here. Due to that, this is also off is there. This is also off is there. So two inputs are given to this switch are 0. So due to that, these switches are off. So here is our port 0 becomes a float port. Port 0 becomes a float port. So due to that, we have to use the pull-up register to the port 0. And due to that pull-up register, this VCC is connected to the port 0. This VCC is connected to the port 0. And due to that, our one write from the 8051, it is right on the port 0 is there. So when you one given is there, if pin is connected to the LED will be glow is there. So this is the working of port 0. This is the working of the port 0 is there. So this is the working of port 0 is there. Okay, understood? So here I am giving, so for that purpose, it is you have to connect the external pull-up resistor of the 10K to the each pin of the port 0. Remember these things. Port 0 is contain external pull-up. All other ports are the internal pull-ups are there. But port 0, it is connected external pull-up of the 10K register is there. Okay. So here is you have to write down the write operation. So you have to use the write 0. So how to write the write 0 is there. Okay, I think you can see. राइट ऑपरेशन कसं होते किंवा इथं आपण बहुतेक दिसत नसेल ओके okay, so here is a right operation is there. See, in right operation, what we have to do in right operation is here is a right 0 is there. Okay, you have to input is right 0. Due to that, what is happened? Due to that, your Q becomes a 0 and Q bar becomes a 1. You remember that Q becomes a 0 and Q bar becomes a 1 is there due to the due to the right 0. So means D input is 0. So due to that, Q becomes a 0 and Q bar becomes a 1 is there. So after that, you know that you are working as a input output. So this is control is 0. So it is connected to mux is connected to the Q bar is there. So this mux is goes to the this switch is there. This mux output input is goes to this switch is there. Here you are using the control is there. Control is 0. So output of the AND gate is 0. So output of our AND gate is 0. So output of AND gate is 0. So due to that 0, what this will be off is there. So this will be off because your and get output is 0. So this switch will be off is there. But here mux is given the one input is there, and this mux one input is given to that switch is there. You can say see MOSFET is there. This switch will be on is there, or MOSFET will be on is there. Due to that on, what will happen? This is connected to the ground. There is a ground is there. This is connected to the ground is there. So this port pins is connected to the ground. So due to that, the input is given by this 8051 is 0. It is connected directly to the port 0 is there through that procedure. through that procedure, it is 0 is connected to the port 0 is there. 0, maybe any pin is there, or 1 or 0 pin is there. Understood? So this is the way we have to write and read from the port 0 is there. So in this way, you have to read and write from the port 0 is there. Okay, understood? So how to read and write from the port 0 is there. So from write from the port 0 and 1, not read. You have to write port 0, and port 0 is 0 comma 1 is there. Okay. Okay, understood how to write data from port 1 is there. Okay, so in port 0, the next go to the port 1 is there. So this is the port 1 is there. Same structure is there. Port 1 is, what is the port 1 is there? See, in port 1, we have discussed the read operation in port 1, and then you can understand by using to the port 0 is there, because diagram is present in port 1 is there, and we reverse discuss to the port 0. So port 1 is a pin where there is no bidirectional is there. It is acted directly input output port is there. Bidirectional, there is no need of the mux is there. There is no need of the mux present in the port 1 is there. There is no another pin is there for the control pin is there, because port 1 is directly act as a 8-bit, which is the bidirectional input output is there. Bidirectional input output. So here we are not using any mux is there. Same here, internal from the, it is a internal CPU bus to the D input is there. Same here. Then here is a clock pulse is there. Here Q is connected to the M1 is there, as a switch is there. It is connected to the read latch is there. And here this port is connected to the read pin is there. Read pin or internal CPU bus is there. Okay. So there is no need of the mux is there, because in previous here we are using the mux because one part of this port 0 is act as address data bus, and one part is act as a bidirectional input output port is there. But port 1 is, it is only act as a bidirectional input output port. There is no any multiplexing pin with the port 1 is there. So remember that port 1 is don't have any multiplexing pins are there. These pins are don't have any multiplexing pins are there. So see, same here is there, internal CPU bus is there, same D flip-flop Q and Q bar is there. Then here is the read pin is there. Here is the load. We have to connect it to the this switch. You can say M1 is a switch, or you can say as a MOSFET is there. Through that you have to connect it to the pin to the CPU is there. So see the operation is there, how it works. Write 0 and write 1. Write 0 and write 1 is there. So first we are discussing the 0 is there. So what is the 0 is there? Means when your internal bus is 0, your output should be, you are connected the port pin with the 0 is there. See, if you are giving the 0 to the input from 805 to the port 1 is there, so it is connected to the D port, D pin is there. So D pin, it is 0, so Q becomes a 0 and Q bar becomes a 1 is there. You know that the working of the port, so working of the D flip-flop is there. You know that working of the D flip-flop is there. If input is given to the 0, to that your Q is becomes 0 and Q bar becomes 1 is there. Q becomes 0 and Q bar becomes a 1 is there. Due to that one, what will happen, this our switch, or you can say the MOSFET will be on is there. This switch or MOSFET will be on is there. This switch or MOSFET will be on is there. Due to that on, this VCC is directly connected to the ground is there, or you can say this is connected to the ground is there. So our port is connected to the ground. Our port is connected to the ground. So here input is 0, your output also get the 0 is there. If input is 0, your output becomes a 0 is there. If it is input 0, output becomes a 0 is there. Okay, understood? So this is the 0. So Q is 0, Q bar is 1. This is connected to the this MOSFET is there. MOSFET will be on is there. So VCC is connected to the ground and it is connected to the port pin is there. So your port becomes, output becomes a 0 is there. So next, Next, how to write 1 is there? Yeah, it's very easy. 1 is there. If I am giving the CPU to the 1 is there, what will happen? 1 is there. Due to that one, output of the D flip flop is there. Q becomes 1 and Q bar becomes 0. Q becomes 1 and Q bar becomes 0. This is the working of our D flip flop. We're discussing the first slide is there. So Q becomes 1 and Q bar becomes a 0 is there. So due to that, Q becomes 1 and Q bar becomes 0. Your MOSFET, or you can say switch, will be off because input of the switch is 0. Due to that, input of the switch is 0, this switch will be open is there. Input of become the switch is 0, this switch will be open is there. So it will be disconnect from port 1. So it will be disconnect from the port 1. So this VCC is connected to the port 1 is there. This VCC is connected to the port 1 is there. So your output becomes a 1 is there. So your output becomes a 1 is there. So your output becomes a 1 is there. So this is a write 1 into the port 1 is there. Write 1 into the port 1 is there. So this is the read and write operation of this port 1 is there. So let's go to the read operation. Let's go to the read. You can, why I'm not going there, because there is a mux is there, so some problems will be created. So here there is no mux, so you can understand easily. So read the data from your port 1 is there. Read the data means what? You have to take the data from this pin. You have to take the data from this pin is there. You have to take the data from this pin and you have to given the data to the CPU. You have given data to the CPU. There is no use of the flip-flops. See, one thing just I want to share with you. When you have to read the operation, when we have to read the operation, what we have to do when read the operation, you have to put a value of all the port bits is 1. You have to put all the ports value becomes a, or CPU becomes a 1 is there, or FF is there. Why? See, just see, I'm going to show. If I am giving a Laksha tune just okay, I want to read the operation. Suppose I want to read from 1 here. I want to read here is 1 is there. I want to read 1 is there. From here 1, I want to read is from port 1 to the CPUs, means 8051 CPU or 8051 there. You can say if I am giving input to the 0, if it is 0 is there. Suppose this internal bus is connected to port is 0, because you have to, some part you have to put into your port is there. I am saying when reset the port, what will you have to do? You have to put a value of 1 in the port. Just see. Just I am discussing this point here. Here, when you have to reset the port, all the values should be 1 is there. Value of reset. Why we have to put a value of 1, not 0? Just I want to discuss this point here. Why not 0? Why 1 is there? See, when you are using the read operation with the port, if I am putting a value of 0 is here, if I am putting a value of 0 is there, see what happened. If I am putting a value of 0, what happened? If I am putting value of 0, so Q becomes 0 and Q bar becomes 1. Okay, you know that this is the working of the D flip flop is there. So when you have to put a value of 0 in your port initial value, or you can say reset value, then Q becomes 0 and Q bar becomes 1 is there. Q becomes 0 and Q bar becomes 1 is there. So this, our MOSFET will be on. This MOSFET will be on. So see what happened. The current is coming from VCC. The current is coming from the VCC and our input from the port is 1. So here is current from this port is there. So the current is coming from this VCC and some current is from this port which are connected, for input is given to the 8051. This current will be high and there will be possibility of the damage of this switch, or you can say the damage of the MOSFET is there. The damage of the switch, or you can say the damage of the MOSFET is there. So avoid this. So avoid this, you have to put a value of 1 in CPU. Sorry, value of 1 in your port is there. Due to that one, what happen? If you are giving the input is 1, so it becomes 1 and your Q bar becomes a 0. So it becomes a 1 and Q bar becomes 0. So this pin will, sorry, this MOSFET will be off condition. This MOSFET will be off condition. So when you are working read operation, you have to must put 1 into the input of all the pins of the port is there. Means initial values of the all the input of this port must be 1 is there. All the input of the port must be 1 is there. So remember these things. Remember these things. Why these things required is that when we are giving the 0 to the port, all pins of 0 to the port, due to that excess voltage from the VCC and, sorry, excess current or voltage from the VCC and your input from the port is there, it is possible to internal MOSFET which is present in your port may be damaged. So initially we have to put a value of 1 in the odd pins of the your port is there. So remember these things are there. Okay, understood. So two important question related to that. First question is when you have to reset, you have to put value of 1. Why we put value of 1 into the port? You must give the this answer is there. So this is the way you have to put a value of 1. Means read operation, you have to put a value of 1 in your port, and for write operation, you have to put value of 0 in your port. When you are working with the programming of the input output operations, we have to write a port into the port. Port you have to put value of 0, and you have to read the port, you have to put value of 1 into the port 1. Any problem? Kashanka kunala? Hello. ठीक है. Doubts आहेत का? Any problem regarding this? Okay. You can give the initiation in your chat box also. Chat box also you can write any problem initiation in your chat box. So this is the read. So how to read? Understood why we are putting the 1 is there. So remember these things. Anybody is asked only the question. If you give the answer of this question, then understand that he know the all the port structure of 8051 is there. So see, if it is 1 is there, so it is 1, it is 0 is there. So when we want to put a value of 0 is there, if you want to put value of 0 is there, suppose if you want to give the input is 0, so this 0 will be go to the this pin is there, and it is connected to the internal bus of the 8051. So write 0 to the pin is there. Okay, and if you want to write 1 is there, you have to give the 1 is there. There is no need of connect to the VCC is there. Same operation is there. Your directly port is connected to your pin is there. Directly port is connected to pin. Here is 1 is there. So here is 1. Here is the 0 is there. See, here is 1 input is given. This one is given to here is there. This is 0 is there. So this will be off is there. So port is connected to the 1 is there. This one is directly connected to your 8051 CPU. This one is connected to direct connect to the 8051 CPU. Same working here. If you are working with this port 0, suppose if I am working with the port 0 for the read operation, what we have to do? Here is the 1. See, if you want to 1, we have to write in your 8051 by using port 0 is there. What we have to do? Here is 1 input is there. There is 1, there is 0. You have to input port, so you have to connect to the port to the multiplication. So it is 0, it is 0. So this will be off condition. This will be off condition. So you directly port pin number of port 0. It is directly connected to the input bus to the my input bus to the 8051 is there. If you want to put a 0 here, what we have to do? 0 means again same thing is there. Here is right 1 is same input is there. There is 1, 0 is there. This is 0, 0 is there, and it is connected to the directly it is connected to the input output right pin is there. It is connected to the input output right pin is there. Okay, understood. So this is the working of read operation in your port 0, 0. You are discussing write operation. Same, it is a read operation which is present in your port 1, and here is the same is there. Okay. This is a port 0, port 1. Again, internal structure of the port 2 is there. See, same structure in the port 2 is there. There is no change in there. That's why I'm discussing a lot of points in port 0. Port 1 is same here. Sorry, port 2 is same internal structure of this. Only difference is there. Here is the mux. There is no need to the control is there. Why? There is no need of the controller is there. There is no need of the control is there. Here we are using the address and control is there. Here we are using the address and control is there. Okay. See, same D flip-flop is there. Here we have to use the mux is there. Here we have to use the mux, and here the control pin is which pin you have to connect is there. What is the address? This is what it means address. See, port 2 is there. See, port 2 is contain a pins which is only a address pins there. This only address pins, and what is it is act as an input port. It is address pin and input output port is there. Understood? It is a multiplexing pin is there. It is act as address bus and also bidirectional input port. Address bus and bidirectional input output ports are there. Okay. So here is the bidirectional port is there. See, here is mux is there. When it is 1, it is connected to the address, it is 0, it is connected to the input output is there. So here is same working is there. Same, you have to first only you have to connect the Q is there. Here is the, you have to use the inverter is there, 0 and 1 is there, and this will be on and off is there. Same working is there. If it is you have to give the 1 is there, this is 1, 0, it will be on, and this port will be come to the grid operation. Port to internal structure is there. So it is dedicated to the input interfacing there. There is output port pulled down through the internal pull-up register is there. Okay. See, here is the working of the port 2 is there. And port 3 are the same. It is having the only alternate functions are there. These alternate functions are related to the, these alternate functions are related to this. What is the alternate function? This alternate function of the RxD, TxD, INT0, INT1, T0, T1, and WR and RD is there. So these are the functions related to the port 3 is there. Okay. So this is the working of the port 3. Same here, only we have to give here is we have to give the NOR gate is there, and by using this alternate functions, we have to give the input to this. So see this, if output of the same as that of the port 0 and port 1 is there. Port 0 and port 1, how it is work? It is same work is there. Only difference is that you have to connect the Q directly to the CMOS bus is there. You have to connect the Q to directly to this MOSFET, or you can use it as a switch to the uh, electrical switch to the input is there. Okay, so this is same working is there, same just like our port 0 and port 1 is there. If you can see this working, if you don't understand, then ask me. Same working is there just like our port 0 and port 1 is there. That's why I'm giving the lot of time in port 0 and port 1. Same working here in the port 2 and port 3 are there. So this is same function is there. For only we have to depending upon this on the alternate function is there, 0 and 1 is there. Depending upon that, this will be on and off is there. Port 2 and port 3 is there. Okay. If you have any difficulty, ask me. Or you can interrupt anytime to me and ask the question, sir. There is no doubt of that. Okay. If you have any difficulty, ask me. Just some chats are there. Just somebody wants to explain the port 3. Just I will explain. So take the